those of you taking physics, which is all of you, know a little bit about motion. We're going to talk about the connections between these three things. Position. What's another physics term for position? Displacement. Or what? Okay, change in x would be another one. So we've got position, velocity, and acceleration. I think we've all got a pretty good grasp of what these things are, what they mean in the physical world. And I want to talk just real quick about the connections between them as far as calculus goes. Position we're going to represent with a couple of different things. If we're talking about displacement, the typical letter that we're going to use for displacement is S for a few reasons. D doesn't really work because D represents some other things. So we usually use S, and it's almost always written as a function of time. So we might say S of t. In your physics class, you'll probably usually use X for position. And this kind of indicates that we're looking at a position along an x-axis. Now, it's interesting when we do this, the x-axis is usually the vertical axis, and the time axis is the horizontal axis. Some people have trouble wrapping their minds around that, but that's the way it works because of the independent-dependent variable relationship there. I will use both of these. I'll try to use X a little more just to make you a little bit more comfortable with it because that's what you'll be using in your physics classes. But more important than the variable we use, what happens when position changes? So if I move from one position to another, what happened to my velocity and my acceleration? They're changing, right? Okay. If I'm standing still and my position is not changing, then what's going on with my velocity? It's zero, right? Well, if my position is changing, let's say that my position changes by 2 feet every second. Okay, so we've got some units there, feet per second. Well, what does feet per second kind of indicate? It's a velocity, right? Now, I'm using the term velocity rather than speed here. I've used speed in the past. What's the difference between velocity and speed? Direction. Speed is always positive, right? Actually, the way we define speed in math is speed is the absolute value of velocity. So speed is always positive. It doesn't matter if you're driving your car and you're going forward, or if you're driving in reverse, or if you're driving toward some origin, so your house or your school or whatever you want to decide is the origin. It doesn't matter if you're getting closer to it or farther from it. Your speed is just how fast the car is moving along the road. The velocity has a direction. It has a positive or negative direction usually. If you get into two-dimensional velocities, then it has you have an x velocity and a y velocity. We won't get into that. That's more of a multivariable calculus type problem. But it's a change in your position. It tells you how fast your position is changing. So since it's a rate of change, it's going to be the derivative. So it's going to be the derivative of your position. Your velocity tells you how fast your position is changing, or the rate of change of your position. And remember, the derivative is the rate of change. So the derivative of velocity, we would write a couple of different ways. We might write dx dt. So a change in x with regards to a change in time, or with respect to a change in time. Or what would the prime notation look like? It would just be x prime, or x prime of t, indicating that it's a function of time still. So if we know the position at any time, the position x at any time, then we can use that position function to determine the derivative of that position function, which turns out to be your velocity. If your position is getting smaller, then that means that your velocity is going to be negative. If your position is increasing, you're moving away from some origin, then that means that your velocity is positive, right? Okay. When my velocity changes, let's say that I'm going to start here at this spot, and I start walking slowly, and I slowly increase my speed. So I go faster and faster and faster. my velocity is increasing. So the rate of change of my velocity is going to be positive. What does that tell me? That I am accelerating, right? So the acceleration is the rate of change of velocity. So we would say that, let me introduce a variable for velocity here. We'll say that the velocity is dx dt, or velocity with respect to time in the function notation is x prime of t. Then acceleration is going to be the derivative of velocity. So since velocity is a function of time, when we take the derivative of this, what do you think that would look like in Leibniz notation? I'm going to write this up at the top because I'm out of room. What would that look like in Leibniz notation? The derivative of velocity with respect to time. So it would be dv dt. So acceleration is going to be dv dt. Now, this is the tricky part. We're getting to higher order derivatives, right? I'm going to show this to you now. I'll explain it to you later why it looks like this. But since we're taking the derivative of a derivative, if we want to write this in terms of our position, we took dx dt, and then we take the derivative of that. It's going to be written like this. So it's the second derivative of x with respect to t. Notice that the square is on the differential operator here, on the d here, and it's on the entire differential here, the dt here. Okay, so what this means is, or another way to write it would be with the x out front here. So we're taking the differential operator with respect to t twice. So it would be d squared dt of x. But usually we would just leave the x up top. In Lagrange notation, acceleration is going to be, I'm out of room again. The acceleration with respect to time is going to be what? The derivative of velocity, so it would be v prime of t. Or, if we want to write it in terms of position, it's going to be the second derivative. How do you think we're going to show that? 2 primes, yep, exactly. So it's going to be the second derivative of x with respect to time. So it would be x double prime is the way you would usually read that.